Hello students, welcome back. The next topic is section 5 of this notebook, tangency problems. Please recall that the derivative is, as a matter of fact, the slope of tangent line. These quantities correspond to slope of secant lines, and as the second reference point gets closer and closer to first, these secant lines are converging into tangent line, and what do we get? The instantaneous rate of change, or the derivative, is the slope of the tangent line. So if you're looking for a tangent line, the derivative computation is way to go. As a matter of fact, we're going to get this kind of step-by-step process. Basically, we are looking for an equation of a line like this, the slope point equation, and x0 is typically given. How do you find out y0? By plugging in and doing the computation. And then you have to find out the slope. In order to find out the slope, you need to find out the derivative function, and then derivative evaluated at x0, that's the slope. Putting everything back to this slope point equation, you're going to get desired answer. Now if you break up the parentheses and simplify, you're going to get the slope intercept equation, but I don't care too much about simplification, so it's perfectly okay to leave it as the slope point equation as far as I'm concerned. Let's see, here are a couple of problems. Okay, there's a good one. Let's find out the y-coordinate value. By the way, this is what you're looking for. This is what you're looking for, and here x0 is given as 3. So the equation of the tangent line you're looking for must be of this form. Y is equals to m, we have to find out. So this is going to be the final form that you're looking for. Okay, first let's find out y naught. Here's my function. I'm plugging in x equals to 3. So we have 9 over 2 minus square root of 9. Square root of 9 is 3, isn't it? So this whole thing is, let's see, 9 over 2 minus 6 over 2, so that's 3 halves. So this will be 3 halves. I hope I did the computation. I hope my computation is right, but even if it is mistake, wait a minute, there's an easy way to check it. Let's see. Yeah, 3 half is correct. Okay, let's go to the next step. Let's take the derivative. Derivative of this, let's see, power comes out of coefficients, so 1/2 times 2, so x, and then this one, okay, let me rewrite the problem first and then do it. I remember this problem. I wrote this problem in a quiz and a lot of students made mistake here. Square root of 3x is not the same as square root of 3 times x. x is inside. So you get square root of 3 times square root of x, or equivalently square root of 3 times x to the 1/2 power. So the derivative function goes like this: 1/2 times 2, so x minus square root of 3, and then multiply by 1/2, and then subtracting 1 from the power, and this is a derivative function. I think I skipped too many steps. Okay, square root of 3, and then multiply by 1/2 x to the negative 1/2 power. That's the power rule, straight ahead power rule, coefficient, and then the power rule, coefficient, and then the power rule. And then let's simplify. X minus square root of 3 over 2x to the negative 1/2 power. That's the derivative function. And let's find out the slope. Plugging in x equals to 3, so here you're plugging in x equals to 3. And you can punch in the calculator as a matter of fact, but I don't have calculator with me, so I'll have to do it hard way. And then this one is negative power, so you have to go down, and then 1/2 power, so this is square root of 3. And do you see cancellation? Those square root of 3's cancel out. I have 3 minus 1/2, which is 7/2. That's the slope. Therefore, we're gonna get the equation of the tangent line like this. Slope 7/2 x minus 3 plus 3/2. There you go. If you break up and then get slope-intercept equation, that's fine, but I'd rather stay at slope-point equation. There goes the full solution. Let's see if I did everything right by opening up this answer key. And if everything right, oh my, there's something wrong. Oh yeah, here 3 minus 1/2 is 5/2, not 7/2. That was the only mistake. Okay. Moral of the story, use your calculator. I had to do my mental math because I didn't have calculator with me. If you have calculator, use it by all means. Okay, otherwise everything is the same, so let me just remove this and go back to this answer key here. y0, plugging in and computation, and f of x is like this, the derivative computation, the power rule, plug in and simplify, and therefore we have the slope point equation of the line. The last two lines, those are necessary. This is perfectly great answer. And then if you break off the parenthesis and get slope-intercept equation, oh, excuse me, I forgot. The problem explicitly said find the slope-intercept equation. I hate this kind of problem. I must have copied this problem from our textbook. Okay, the problem explicitly says slope-intercept equation, so you cannot stop here. Break up the parentheses and simplify. You get the slope-intercept equation. I hate it. And in my exam problem, I've never written this kind of problem. I accept any kind of correct equation of the line as correct answer. So don't pay too much attention to simplification. Anyway, here is the justification through Mathematica. of the tangent line. I guess the next problem will have to be done in a separate video, so let's stop here.